So let's talk about post hoc tests. Topic 2 today. So you have a significant F, now what? Maybe you transform your data, whatever. But you now have, the thing comes out, it says P is less than 0.05, and it's like, yes, it's a good day when that happens. Makes you happy, right? So what do you do at that point? Remember what our null hypothesis is here, right? Our null hypothesis is that HO is mu1 equals mu2 equals mu3 equals mu sub k. There are k groups in the experiment. So that's our null. So when we get a significant F, all it's saying is it isn't telling us what groups differ, it tells us that two groups differ. At least two. Could be all of them, could be just two. But it means at least two groups differ. Okay. All right. But which ones differ from each other? It's a good question. That's what these kind of tests do. What these all are, basically, are a series of t-tests. They really are just t-tests. They're using different kinds of error tools. Okay. So the first one is the Bonferroni correction. It looks to me like a kind of food. I always thought that. It looks like something you'd want to eat, big plate of Bonferroni. That sounds delicious, doesn't it? So this basically is the simplest one. This just is t-tests. So what you're doing with the Bonferroni correction is you're doing t-tests, but think about this. Let's say you've got just a 3-group analysis of variance experiment. Very straightforward. 3 groups. Well, how many comparisons, possible t-tests are there with 3 groups? Let's see. Group 3 versus group 2. Group 3 versus group 3 versus group 1. Group 1 versus, oh, we got 3 comparisons, right? Yeah, that makes sense because it's 3 times 2 divided by 2. Okay. Well, now we have to set our alpha level for our t-test, if we were doing 3 t-tests rather than analysis of variance, at 0.05 divided by 3. Right? So what this does is it allows us, it takes that into account and gives you a new critical t-value that gives you, with the right point, like the right value for alpha. So it's 1 over n times alpha, where n is the number of corrections. In other words, how many comparisons you make. So now your alpha level, for example, if you had 3 comparisons, is 0.05 divided by 3. So that's your new, where your critical value is, okay? And it's just a t-test. You look at that and go, look, group 1, group 2. Oh, why is it 2 times the mean squared error? Think about the bottom of a variance. What's at the bottom of a variance equation? Bottom of a t-test, right? We have a 2-group t-test. We're going to have s squared 1 divided by n1 plus s squared 2 divided by n2. Oh, or you mean 2 times mean squared error is s squared, right? Is s, right? S squared. So it's 2 times that divided by n. That's all this is. It's a simple t-test. By the way, you never do these by hand. When you're doing analysis of variance with SPSS or PSPP, just choose post hoc tests. It's a little option. Go to the options part, choose it, and you can choose which ones you want. There'll be a whole bunch that I'm not even going to talk about today, too. I'm talking about some sort of popular ones, basically. So the Bonferroni procedure is probably the easiest one to understand. It's just really a couple t-tests. It looks almost exactly the same. This is called the studentized range. X bar sub L divided by, subtracting X bar sub S. Largest minus the smallest. That's all it is. And that then gives you a range. That's why you get this thing called Q sub R. And then what you do is you look up how big a range is significant. So this just gives you a number, and let's say the number it gives you is 6 when you do the calculation. Then you look and see, are any of the numbers bigger than 6? the way they're different, then they're significantly different from each other. It's very, very straightforward. Okay? So it gives you a range. So if two means are different by enough, they're then significant. This just tells you how big enough is. Newman Coles. No one does these by hand. I don't know how to, these are the ones that I don't even know the formulas for. I can derive them, but who cares? That's not that impressive. So what I'm saying is, people don't tend to know these formulas, and I wouldn't be testing you on these formulas. That would be crazy. Where did I put my mouse that I use as a remote? Oh, there it is. Okay. Right by the microphone.
Hello.
The Newman-Coles test. Okay, how's this one work? Well, you calculate that, you get the Q value for a specific range. Like, how big is the range? Remember that range thing we just got in the last one? This is taking that into account. So you do that calculation, you look it up, you get a number, multiply it times this, and it gives you, this is called W. And it just is the range. Again, this just says how big a range does you have to get between two means, make them different. So if this comes out at 8, any two means that are different by 8 or more are significantly different. Note they all have, you might say, well, Dave, why don't we just do this in the first place? Well, they all have mean squared error in them. You have to do the ANOVA anyway. Right? All right. So any set of comparisons with range R. So, but again, like what it says is, if any of these comparisons are bigger than whatever we get, that's significantly different. So again, all with a range of 3. So to come on, instead of 8, I used 3 on the slide. But whatever the hell the number is, as long as they're different by more than 3, in our case here, then they're different. Here's another one. I know this is almost the same. Tukey's HSD. You know why it's called HSD? Because he called it, he said it stands for honestly significantly different. So Tukey's HSD test uses just uses the largest possible range between two means. It does largest to smallest. They're all basically they're all variations on a theme. They're all just versions of a t-test. They're just versions of a t-test. That's all they are. Okay? That's all these things are. So you might ask, which one should I use? First of all, you don't just do all, like this is what most people do. You shouldn't really do this. What most people do is they do an analysis and just click yes, 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 the option for all of the different post-hoc tests and just do all of them. You shouldn't do that. But that's what people do. I'd stick to one within a paper. So I would be suspicious if I was reading a paper and someone said, oh, in this one we didn't use that post hoc, we used a different one. The first thing I would think of is, oh, because it didn't work this time. I've used HSD mostly in my life, and it's fine. It's a pretty common one. There are different ones that have different levels of, they're more or less conservative. So they're more or less likely to find a difference. So, for example, there is an incredibly conservative test called the Scheffé test that I've even told you about. The reason I'm not telling you about it is it's so conservative that when you use that test a lot of times, if you've got a significant F, it still says none of your means are different. No. So you don't want to use that one. On the other hand, sometimes the Tukey HSD, if you're just using it, will tell you two means are different that aren't. Okay, so you got to be kind of careful with these things. I will say that I actually don't like them. One of the reasons we're doing this for 12 minutes is the second part of the thing, is that I think the point of analysis of variance is to look for a pattern in your data. Okay, so if I see a pattern and I have a significant F, I can look and say, I can explain the pattern. The reason I'm getting that is because of that I'm getting a significant difference, my F, is because of this pattern that I got. If I'm actually interested in individual comparisons between groups, just design that experiment. That's a very the view I have, by the way, is a minority opinion. So it's not like it's quite a minority opinion, frankly. So I'll just let you know that most people don't think like me, which is probably good. The world needs fewer people like me, not more. But yeah, it's the case that I'm not huge on these things. But you will find that you'll probably have to do in your thesis, stuff like that. Okay? And all it involves is just clicking something. It's that simple. Like just you go to the options, it'll have post hoc tests, and you just click. And most people just click them all. But Tukey HSD is probably the way to go. I mean, it's got a balance between being conservative and not. Like it's just the right level of conservative as far as the decisions it makes. Questions about post hoc comparisons at all? Right. So a post hoc comparison, what it is, if you want to know like a definition, a post hoc comparison is a statistical test that is to determine what means are different from what other means after you get a significant analysis of variance. It's always after you have a significant ANOVA. Okay. All right. Okay. Questions? I see a lot of you are getting the assignment done. That's great. When's it due? Today. Oh, today. That's why you're all getting it done. Great. Get it done. So, good.
Was it not today 2 hours ago?
Yeah, I think it was actually earlier today. Yeah, I'm just an idiot. So if you haven't done it yet, I'd get it done really, really soon. Because I clearly haven't looked at it yet. I'll see that it's late a couple of minutes. I don't care. All right. Anything else? All right, good. That's it then, because we've learned all about comparisons and transformations. I will see you in the future. Thanks, guys.